Hello everyone, this is Edexcel Science channel. This is going to be my first video and we are going to solve Physics Unit 1, Mechanics and Materials from October 2024 for Edexcel International Advanced Level. If you have any questions or confusions, please let me know in the comment section and don't forget to subscribe the channel. Let's look at the first question. Which of the following units is equivalent to the watt? Now we know that the watt is actually the SI unit for power. Now, if we write down the general formula for power, it is work done divided by time taken. And the SI unit for work done is joules, and for time it's second. So it becomes joule per second. That is why number D is the answer. Question number 2. Which row of the table gives two vector quantities? Clearly, A is the answer. Why? Because acceleration and weight both requires a direction. We know that weight is always going to be vertically downward and acceleration always has a direction. If we look at option B, C, and D, kinetic energy, strain, Young modulus, and mass, all of them are independent of a direction. That is why they are not the correct answer. Question number 3. The displacement time graph for a person running a race is shown. Which of the following gives the average velocity of the person? So the goal of this question is to find out the average velocity. To answer this question, we would at first have to look at the shape of the graph. As we can see that the displacement is increasing per unit time. And they are asking us to find out the average velocity of the entire journey. So let's look at the options. Option A, area between the curve and the x-axis from 0 to 4. So they are telling us that we should find out the area under the graph. But that is not the correct answer. Why? Because the area under the graph of a displacement versus time graph has no significance. We know that if you have a velocity versus time graph, the area under the graph should give you distance. But for a displacement versus time graph, that is not the case. The area under the graph has no significance. Gradient of a tangent to the curve at 4 hours. So they are telling us that if we make a tangent over here and then find out its gradient. But doing that will only give us the instantaneous velocity at time 4 hours. That is why both B and C are not the correct answer, because if we follow this method, we will only find out the instantaneous or the momentary velocity at this particular hour. That is why number D is the correct answer. What does it say? It says that displacement at 4 hours divided by time of 4 hours. So basically what they're telling us that you have to take the total displacement of the journey and the total time taken. That is how you find out the average velocity. Question number 4. The photograph shows a cable car hanging from a cable. The cable car is in equilibrium. Okay, so that is something important that we should note down. It is in equilibrium. Which of the following forms a Newton third law pair of forces with the weight of the cable car? So they're asking us that, okay, if we try to draw a diagram, so let's assume that this is the cable car. So they're asking us that if there is a weight vertically downward, which of these force will become the Newton third law pair? Which one will become this one? So let's read the options. Air resistance acting on the cable car. This is not the correct answer. Why? Because if the cable car is going this way, then the air resistance will be this way. It can never be the Newton's third law pair of weight. So the basic rule of thumb is that any frictional force will act in the opposite direction of motion. Number B, gravitational pull of the cable car on Earth. So they are basically saying that there is a gravitational pull of the cable car on Earth. So if we make this diagram a little bit smaller, now all of this is happening where, guys? On Earth, right? So we can say that this is the weight by which Earth, this is the force by which Earth pulls the cable. And in return, the cable will also pull Earth. So that is why B is the correct answer. And we know that every body of mass will attract each other. But let's see why C and D is not the correct answer. Upthrust of the displaced air acting on the cable. Now, that is not the correct answer because the density of air is very low, which is why upthrust is totally ignored. Normal contact force of the cable car on the cable, that is also not the correct answer. Question number 5. A box slides down a slope at a constant speed. Weight and resistive forces both act on the box. Which one of the following is a reason why the speed of the box is constant? So let's draw the scenario which will make it easy for us to answer. So there is a box on a slope which is sliding down, and they're saying that the weight and the resistive force will always be in the opposite direction. All of them are working, all of them are acting on the box, but somehow the speed of the box is still constant. Why? That is the question. So let's look at the options. Number A, the component of the weight parallel to the slope is equal to the sum of the resistive forces. Okay, I think that is the correct answer. Why? Because if we make a if we divide the weight into its components, then one component will be in this direction, which will be, let's say if this is theta, then this will be theta. So this will be weight cos theta, and another component will be in this direction, which is weight sine theta. Now, we don't really require all of these to answer such a question, but I'm trying to explain things in as much details as I can. Now, as we can see that this one and this one will balance each other out. If the velocity of the box is constant, it basically means that the acceleration is zero. For acceleration to become zero, the resultant force must be zero. And for resultant force to be zero, all forces in all direction must be equal to one another so that they basically cancel each other out. So in this case, if the resistive force is equal to the parallel component of weight, then these two will cancel each other out, and there will be zero resultant force as zero acceleration, which will make the velocity of the box constant. Question number 6. A person stands on a moving staircase. The moving staircase increases the the gravitational potential energy of the person by 5,000 joules in a time of 42 seconds. The efficiency of the moving staircase is 0.6. Which one of the following expressions gives the power input of the moving staircase in watts? Now, we know that the general formula for efficiency is useful power divided by total power times 100. Now, we are going to take information from the question and just plug it in the formula. So the efficiency is 0.63. Actually, we should not use 100 over here because the efficiency is not given as percentage. If it was given as percentage, then we would have used 100 on the side. Now, the useful power is that when a person is using the staircase, their energy will increase by 5,000 in a matter of 42 seconds. So we can write something like this, that we know on the side that power is work done by time taken. So work done is 5,000 divided by time taken is 42. So let's plug that in. Divided by our total power. Now, power is equals to 5,000 divided by 42 by 0.63. And that is why number C is the correct, because if we do the algebra, it should be something like, that is why number C is the correct answer. Number 7, a student applies a force to stretch a thin metal wire. Which of the following describes the wire at the elastic limit? Now, we need to at first understand what is the elastic limit. The elastic limit is the point beyond which it will no longer follow Hooke's law and it will be permanently deformed. It will go through plastic deformation or permanent deformation. So if we look at the options, which of them at the elastic, so it should deform elastically. If it is at the elastic limit, then it should deform elastically still. But if it is beyond the elastic limit, it will deform plastically. Number 8, a student uses a wooden bat to hit a stationary ball of mass m. Okay. As the bat hits the ball, the momentum of the bat decreases by delta p. The ball then moves with a velocity of v. The student then uses the bat to hit a stationary ball of mass 3m. The momentum of the bat decreases by 2 delta p. Which one of the following expression gives the velocity of the ball of mass 3m after being hit? So, the first thing we need to do in this type of question is that we need to notice that there are two separate scenarios. One scenario is for the ball with mass m, and another scenario is for the ball with mass 3m. So we need to find out how does these two scenarios connect with one another. So momentum is equals to mass times the velocity, and the velocity would be momentum by mass. So delta p divided by m. Now, if we go to our second scenario, it should be momentum is equals to mass times velocity. Now, the momentum over here is 2 delta p. The mass is 3m. The velocity is v. So V is equals to 2 delta P divided by 3M. As we can see, this part is for this, and this part is for this. Now, what I have done in both of these scenarios is that since the question asks us to give the velocity, I have calculated the velocity for both of these scenarios. Now, as we can see that this does not match with any of the options. However, if we look at this part, delta P by M, in our first scenario, we have found out that delta P over M is equivalent to V. So what we can do is, we can just substitute V over here, and that is why this is the answer. A rule of thumb for any question like this would be that if there are two scenarios, you try to find for both of the scenario what the question asks you. And then you can just substitute between them. That will give you the answer for sure. Question number 9. Two boats, A and B, are pulling a ship. Each boat is attached to the ship by a rope as shown. Okay, so there is boat A, boat B. They are at different angles to the ship, to the horizontal, and they are held together by a rope. Okay, fine. The force of boat A is Fa. So let's try to write this down in the diagram. And this is Fb. Which one of the following expressions gives the forward component of the total force? So as we know that if a force is at an angle, then we need to divide it into different components. We need to divide it into a vertical and a horizontal component. So let's do that. For force A, we know that the component is gonna be this and this. We are going to divide the component from the tail of the force. Okay, so this is gonna be Fa sine 31, and this is going to be Fa cos 31. For force B, the component is gonna be this and this. So this is going to be Fb sine 27, and this is going to be Fb cos 27. As we see that the total force of the boats on the ship, these two forces are not affecting the ship. However, these two forces are being used to move the ship forward as they're in the same direction as the ship. So the total force should be the addition of both of this. So whichever one matches this would be the answer. So it should be number C. Question number 10. A student uses a piece of wood on top of a cylinder. He stands on the wood with his feet at distance X and Y from the cylinder. So he is putting 1 foot over here and 1 foot over here. Okay. The weight of the student is W. And the diagram shows that the force of each foot acting on the wood. Okay. All right. The wood is horizontal and in equilibrium. Okay, so this is a very important point. The weight of the wood is negligible. Okay, fine. Which of the following expression is equal to the weight of the person? So we can see the diagram, and the fact that they're giving us different forces and their distance from a particular point, This actually tells us that this is a moment question. And in a question of moments, if it says that it is in equilibrium, then we know that the clockwise and the anti-clockwise moments must be equal. So all we need to do for this question is to develop an equation using the principle of moments. Now, for the clockwise moment, this is the clockwise moment. So my force times the perpendicular distance from the pivot. We are taking this point as the pivot. So this is my pivot. So this has a distance of y. And the anti-clockwise is this force. So F times X. Now we need to do the algebra to make weight the subject of the equation, and then hopefully we find out the answer. So W minus F is equals to Fx divided by Y. So number C is the, not C, sorry. Fx, yeah, number A is the correct answer. Yeah, this one matches with A.